Bismillahirrahmanirrahim. All right. So last time we're looking at different examples, couple of examples of Fourier transform. Let's talk about basic properties of Fourier transform. The first property is linearity, or it's also known as superposition. All right. It's also known as superposition. So here's the property number one. So let x1 of t has a Fourier transform. The reason I'm writing it crooked is just to show this is a Fourier transform of x1 of f. All right. Let I have a function x1 of t that has a Fourier transform x1 of f, and I have another function x2 of t that has a Fourier transform of x2 of f. Then this property is saying alpha 1 times x1 of t plus alpha 2 x2 of t, some variable that I'm multiplying. So basically it's just some variable that I'm multiplying my function 1 plus some variable multiplied by my function 2. That would be just like saying alpha 1 x1 of f plus alpha 2 x2 of f. All right. So basically what it's saying is this. This superpositioning is telling me the response to how many what are the sum of inputs. Basically what I'm saying is this. What is just like sum of individual responses. So you will calculate the Fourier transform. You have a function that has some variable multiplied to it. Basically you're summing the individual responses. Basically, so the first function, you'll take a Fourier transform. If you have a second function, you'll take a Fourier transform. You're just basically summing them up, adding them up. And why we are adding it, just always remember that integration is a linear operator. That's why we're doing this. So that's all it is. Whatever you do in time domain, you will find the Fourier transform of it and just multiply by that the variable. Now the next property is this, time shift. If x of t, if I have a function x of t, definitely the Fourier transform of this function is x of f. Then x of t minus t naught. What would be the Fourier transform of this? This is going to be x of f times e to the negative j 2 pi f do. Right, that would be the Fourier transform. If I have a function x of t, that is a Fourier transform of x of f. Now I have a function which is shifted in time, some negative to value. So in time is being shifted. What is the Fourier transform? Is going to be that function itself times it by e to the negative j 2 pi f t0. All right, let's try to prove this. So let's do a small proof. All right, proof is this. Let's take a Fourier transform x t minus t naught. All right, in order for me to do the Fourier transform, what is the definition of my Fourier transform? T is equals to from negative infinity to positive infinity, x of t e to the j negative j 2 pi f t dt. Okay, so let's do a small proof of this. So let's calculate the Fourier transform of this. So in order for me to calculate the Fourier transform of this, so this is t as it goes from negative infinity to positive infinity. What is my function? X t minus t naught e to the negative j 2 pi f t dt. All right, in order for me to do that, I'm going to make few substitutions. All right, so I'm going to do some substitutions here. And these substitutions are going to be simple. We're going to assume my u is t minus t0. All right. And t, then if I want to solve for t, t is just going to be u plus t naught. And dt is going to be my du. We're going to make these few substitutions here to do it. So now based on this, t as it goes from negative infinity to positive infinity. So this is just going to be x of u. All right, t minus t0 is going to be x of u. Now e to the negative j 2 pi f, and this t is going to be u plus u plus t naught. I hope you're getting it. And this dt is just going to be du. All right. So far, so good. So when I have bases same, I'm adding powers, so I can just split them up. So what am I doing is this: as t goes from negative infinity to positive infinity, I get two of these guys. All right. I'm gonna bring one out. E to the negative j 2 pi t naught. All right. I'm sorry, I forgot to put an f. Why? You guys, I can also rewrite this as this. I can also rewrite this as this. Negative e to the j 2 pi f mu times e to the negative j 2 pi f t naught. All right. So I'm just simply writing it like this. According to this, I just simply use that substitution, but I can do it like this. Since its integration limit, the variable that I'm integrating is with respect to u, so t naught is just nothing but a constant, so I've taken that out. All right, I hope you're getting it. I just simply taken that out, so I'll end up only with x of u e to the negative j 2 pi fu du. All right, now it's simple. Now, I'm sorry, I forgot to change the variable. Since t was going from negative infinity to positive infinity, then u is also going from negative infinity to positive infinity. So now it's quite simple, isn't it? To be now this is just e to the negative j 2 pi f t 0. Look at this. What is the Fourier transform? What is the inverse Fourier transform of this? This whole thing is going to be the inverse Fourier transform of this is going to be x of f, isn't it? Right here, x of f, and this is that kernel that is coming out. And then if I were to take this, is exactly like this. So I hope you like this small tutorial on basic properties of Fourier transform. And if you have any questions, just leave it in a comment section, and don't forget to subscribe to my channel.